Hey everyone, this is 6.5, Interpreting Quadratic Equation Roots. So our learning goal for today is that we're going to determine the number of roots a quadratic equation will have. Now remember, roots are the x-intercepts. So we're just going to figure out how many roots or how many x-intercepts a quadratic has. So remember, the term root really just means that we're solving for x in a quadratic equation. Now, sometimes we can solve by factoring, in which case we have the x-intercepts or the roots. Other times, and more recently, we've been using the quadratic equation to solve for the roots of any sort of quadratic. A quadratic equation may have two, which is what we're really used to, two roots. It could also have one root, right? And it can also have zero roots or no roots. So here's a question that might come up. Without solving the equation, like we've done the quadratic formula, we know how long it can be. So without doing that, how can we determine just the number of solutions or perhaps the number of roots? Let me go ahead and write roots in there. A quadratic equation in the form, standard form, ax squared plus bx plus c equals 0 will have. Okay, so we're basically saying, well, how many roots does this thing have? Does it have 0? Does it have 1? Or does it have 2? So before we get into any of that, let's just use the quadratic formula and kind of have a look at what's going on down here. So we have three equations, right? A, B, and C. Three quadratic equations. Notice how they're all in the form ax squared plus bx plus c equals 0. They're all in that form already because that's the form that we need to have to do the quadratic formula. So let's look at this first one. The a value is 1, the b value is -2, and the c value is -3. We go ahead and we do the quadratic formula, and we end up with 2 plus 4 divided by 2 and 2 minus 4 divided by 2. We have two solutions or two roots here. Yeah? And that's probably what we're used to. Now, there may have been a couple scenarios in the homework from the other day that, you did the quadratic formula. Let's go ahead and look at B. We do the quadratic formula, and you notice that you might get a 0 under the square root. Because now, if you add 0 and take away 0, it doesn't really change the result. So you're just going to get one answer two times. So we just call that one solution, right? And lastly, this might not have come up a whole lot, but it will come up a little bit today. We do the whole quadratic formula in part C, and we notice that we end up with a negative number underneath the square root. And we're not actually able to calculate a negative square root without getting into imaginary numbers, and we're not going to get into that. So our calculator will always give us some sort of math error whenever we try to take the square root of a negative number, in which case there are no solutions. And the reason for that is because we can't take the square root of a negative number. So the big idea here is that we're really focused on, I'm going to pull out my green highlighter, we're really focused on the number underneath the square root. Because if we actually get a positive number underneath the square root, of course, we can take the square root of it, we can do the plus minus of whatever that number might be, and we're going to get two solutions every single time. Now, if that number underneath the square root is exactly 0, when we add 0 and take away 0, like plus and minus 0, it's not going to change the result, so we'll always end up with one solution. And of course, in this last scenario in part C, if we end up with that negative number underneath the square root, any negative number, then, well, we can't really take the square root of a negative number. Therefore, we know that the quadratic will have no solutions or perhaps no x-intercepts. And that's essentially it. I could almost stop teaching right now, and that's what you're focused on is underneath that square root. But underneath that square root, it has a very special name right here. It's that b squared minus 4ac. And we call that the discriminant. The discriminant. Now, its value will tell us how many solutions or how many roots the quadratic that's in standard form, right? Don't forget that, will have. So this is key information. That's why it's written in red. if b squared minus 4ac, which is, I'm going to now call it the discriminant, if the discriminant is greater than 0, then we have two solutions or two roots. Meaning, if this thing is positive, if this b squared minus 4ac is a positive outcome, then yeah, we're going to have two roots. Now, if this is equal to 0, so if the outcome literally equals 0, we know that we're going to have just one root or one answer. And if the discriminant outcome is less than 0, basically saying if it's a negative outcome, then we have no solutions or no roots. Okay? Example 2, sorry, I had to pause the video for a moment there. Example 2, it says here, use the discriminant, which we know is underneath the square root, it's just b squared minus 4ac. Use the discriminant to determine the number of zeros, or the number of roots, for each of the following. So let's have a look here. Let's have a look at part A. Again, we got to make sure that these quadratic equations are in standard form. ax squared plus bx plus c equals 0. We want it to equal 0. And from here, we can just pull out the a value, the b value, and the c value. So you know the a value is 1, the b value is 4, the c value is negative 7. Very similar to how you would use the quadratic formula. So what we're going to do is we're going to plug in these values. 4 squared minus 4 times 1 times negative 7. Now, you could really punch this all into a calculator and get one final answer, but I'm going to show my work. I'm going to take my time here, and this is where a little bit nastiness can happen, and that's why I highly encourage you to show your work, because when we're taking away a negative, we also got to remember that's like adding a positive. So we end up with an answer of positive 44. So we say, well, since the b squared minus 4ac is greater than 0, meaning it's a positive answer, there are two roots. Yeah? Two roots. That's this one right up here. Okay, let's try another one. Is this in ax squared plus bx plus c equals 0 form? It looks to be. So we know the a value is negative 2, right? The b value is 3, and the c value is negative 9. Okay? So what we're going to do is plug this into the discriminant, just like that. So we have 3 squared minus 4 times negative 2 times negative 9. And we punch this into our calculator, and 9 minus 72 is negative 63. So we get a negative outcome. So since the discriminant is less than 0, so 0 will get the mouth, or the greater than symbol. The mouth always eats the bigger one, right? So there's going to be 0 roots because we have a negative outcome, meaning the discriminant is less than 0. Lastly, another example, and that'll be right here. The last outcome here, 4x squared plus 4x plus 1 equals 0. It is in ax squared plus bx plus c equals 0 form. We call that standard form. So we know the a value is positive 4, the b value is positive 4. I wrote a again, whoops. And then the c value is positive 1. We're going to plug this into the discriminant. 4 squared minus 4 times 1. No problem here. 16 minus 16. Oh, would you look at that? And it equals 0. So, because the discriminant is equal to 0, we can say that there are just one roots. Okay, one root. Singular, not plural. There's just one root. Or there is one root. Okay, this isn't English, but I think you get the idea. Okay, and that's pretty much it. That's the whole lesson right there. There's either going to be 2 roots, 0 roots, or 1 root. Okay, so the homework. Well, some of the homework stems in here. So here's some homework. It says use the discriminant, right? Discriminant we know is b squared minus 4ac. That's what the discriminant is. To determine the number of solutions that each equation has. So we're seeing exactly what we did in the previous example. Is it greater than 0? 2 solutions. Is it less than 0, like a negative number? 0 solutions. Or is it exactly 0, and that would mean 1 solution? Okay. So what I'm going to do here is I'm going to give you some answers. 2 roots, 2 roots, no roots, no roots, 1 root, and no roots. Okay, so go ahead. You can maybe even pause the video here, try the 6 of these on your own. But I do want to caution you. You know, as you progress into this, look at this one. We got to make sure that all of these are in ax squared plus bx plus c equals 0 form. Some of them are not. So be very, very, very cautious of that. Like, look, b is not, c is not, and F is not. So just be cautious of those. You will have to rearrange. So perhaps we can even just show you what's going on here. So for this for part C here, we would have to take the 5x and the positive 12 and bring them over to the other side of the equation. And you know when that happens, they change their sign. So they went from a positive 5x to a minus 5x and to a plus 12 to a minus 12. And we collect our like terms, and yeah. So we have 3x squared minus 3x minus 12. And what happens here is that this becomes our a, b, and c values. We plug them right into the discriminant, and we should get a negative outcome if my math is done correctly. Okay, great. There is one more piece of the homework that is attached to the note here, and it's this one right here. And we have done questions similar to this. It says the formula h equals negative 4.9 t squared plus 60t plus 3. Here's our formula here. It models the height of a projectile on Earth, where h is height in meters and t is time in seconds. So there's 2 parts here. The first part is how long would it take the rocket or the projectile to fall to Earth? Round your answer to 2 decimal places. Now remember, this is a projectile. So if we have a graph, it'll probably look something like this. It'll go way up and way down, right? This question is not asking for maximum height. It's not asking for the vertex. It's saying, well, how long would it take for this thing to hit the ground? So t is our independent variable. It's our time. And then h is our dependent variable, which is the height, right? So we want to know how long. So what is t when this thing hits the ground? So you might get a negative answer, which we know there's no such thing as negative time, right? And you might get a positive answer, okay? So that's kind of what we're just looking for. We're looking for this positive answer. When is this thing going to hit the ground, okay? And then part 2, or rather part B, it says over what time interval? So for an interval meaning like from 2 seconds to 5 seconds, that's the interval, right? Is the height of the rocket greater than 150? So let's just say 150 meters is about here, for example. And that would mean we want these 2 solutions right there. So what we would have to do is perhaps very similar to the other unit. Maybe determine the roots when h is 150. Yeah. So to recap, part A, for part A, we are just using the quadratic formula with this thing. We're getting the x-intercepts, and we're okay with that. And part B, wherever I have it here, thought I had it somewhere. It's not letting me click on it. Here we are. We wanted to use the quadratic formula on this thing, but when h equals 150. Okay? So give those a try. I believe I do have the answers, and they're down here. So let me get rid of this so I'm able to click on these answers, just so you have solutions. I don't want to leave you here without any solutions. Here's what I got. The interval between 3.387 seconds and 8.858 seconds. You might want to round. I'm not sure. If you do round, you might get a little bit of a different answer. And over here, for the first one here, how long would it take for the rocket to hit the Earth? Well, we know there's no such thing as negative time, so it would take 12.3 seconds for this thing to go all the way up and all the way down and then hit Earth again. Okay? There is also some textbook questions here. They're really, 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 really good. And again, folks, kind of a light day, and that's really good stuff. If you do have any questions about anything here, please feel free to let me know. But other than that, enjoy using the discriminant. It's a super useful tool in grade 10, 11, and 12. And yeah, remember, the one thing to remember, it is called the discriminant. I will probably ask you something like that on a test or a quiz, and I just want to make sure you're spelling this thing correctly. Okay, maybe you got to say it out loud a few times yourself to get the wording down. Okay, well, if you need anything, let me know. I'm always here to help.